Okay, so last but not least, this fourth video is looking at acids, and now I will tell you that acids are probably going to be the most difficult section that you will struggle with. Acids for everyone take a lot of critical thinking and puzzle making to really break down the names. So you may have to watch the video, practice this several times, but don't get discouraged. You will eventually get a hang of it. So to be considered an acid, okay, a compound must have two things. Hydrogen will be the first element in the formula, and two, it must be dissolved in water. Anything that's dissolved in water, we say is an aqueous solution, and we designate it with an AQ after the formula. Now, different states of matter, solid, liquid, and gas also have designations. So S indicates a solid, L indicates a liquid, gas is with a G. Okay, and so for an acid, you will always be looking for the AQ behind the name when naming it. So there's several types of acids. The first one we're going to look at a binary acid. This means there's two elements present. Okay, and so these are called hydrohalic acids. Basically, you have a halogen. Okay, remember that's group 17 plus a hydrogen. Okay, so for example, if I were to have HF with a G in the gaseous state, I would name it according to my binary rules. So just hydrogen fluoride, okay, or even hydrogen monofluoride. But once it's dissolved in water and becomes AQ, it is now an acid. Its name is hydrofluoric acid. We'll talk about the patterns here in a minute. HCl as a gas, we would name it hydrogen chloride or hydrogen monochloride. When it's dissolved in water and it has the AQ, it's hydrochloric acid. By the way, that's stomach acid. HBr as a gas, okay, or a liquid or a solid, whatever other states you could think of, we would name it as hydrogen bromide or hydrogen monobromide. When it's dissolved in water as an aqueous, it is hydrobromic acid. So hopefully you've seen some of this pattern. Okay, if it's an acid in the aqueous form, it's going to have, and it's a binary acid, it's going to have the prefix hydro in front, and it's going to have the ic ending. Okay, and then obviously put acid on the end. This is consistent with all binary acids. Okay, now these first several, these are your hydrohalics. You can continue this pattern with other binary acids. So for example, H2S. The reason why this is H2S is because H plus, S2 minus, if you crisscross it, okay, you get H2S. If it has that aqueous marking, then it would be hydrosulfuric acid. Okay, hydroic acid. Same thing with selenium. Okay, if this were a gas, it would just be dihydrogen selenide. But if it's an acid, hydro, the root of the name, ic, and acid. Okay, let's scroll down. Let's talk about oxy acids. Oxy acids are considered ternary or tertiary, meaning there's more than two elements. These are typically when you have hydrogen paired with some negative polyatomic ion. Okay, now if we were to name this as a gas, it's hydrogen sulfate. Once it's dissolved in water, this is sulfuric acid. Okay, HNO3 as a gas, hydrogen nitrate. Basically, you're just naming the ions like we did last unit. When it's dissolved in water, though, it becomes nitric acid. And so here's some patterns, okay, and you can read through those. Now, you remember our metals with two oxidation states, how we had an us and an ic suffixes? We will apply this same concept to the naming of acids. And so highlight this. This is probably the most important thing for oxy acids. A polyatomic ion whose name ends in ate, when it becomes an acid, the name is ic acid. So, for example, up here, this is the sulfate ion, okay? And so sulfate, when it becomes an acid, is sulfuric acid. A polyatomic ions, let's switch colors here. Polyatomic ions who names an ite, okay, becomes us acid. Us acid. Okay, there are also more, for example, depending on the ion, okay, per and hypo, just like we had in the previous units, you can also apply those to the naming as well. Okay, so ClO4, this was the perchlorate ion, and so as an acid, it becomes perchloric acid. Okay. Same thing with hypo. Okay, that was the hypochlorite ion, and we're referring to this portion here. You got to be able to identify that that's hypochlorite. So if it's an acid, if it has that H in front and it's aqueous, it becomes hypochlorous acid. Okay. Last but not least, your diatomic elements, which you guys should already know. There are 7 diatomic elements that cannot exist as a single atom, and they always have to be as a pair, as a molecule. That's why they're called diatomic. These are your 7. I would like to tell you or remind you of the phrase Brinkelhoff. So BRINCLHONF. Those are your 7 diatomic elements. When in nature, they always exist as a molecule too. And so if you see the phrase hydrogen gas, okay, or pure hydrogen or dihydrogen, any of those combinations of names, you would write it as a molecule of H2. Hardly ever will you ever just write H by itself, meaning that it's not bonded to something else. Okay, so next week we will look at Lewis structures. So for right